Hello students, how are you? We are going to discuss the new topic that is equilibrium constant. We are going to know about the equilibrium constant and its units. Students, we have discussed earlier that what is the equilibrium constant and how it is established. We said that in a reversible reaction, a stage comes when the rate of forward reaction and rate of reverse reaction becomes equal to each other in a speed, but the composition of the reaction mixtures becomes a constant. Then that state is called a chemical equilibrium stage. And when we discussed about the law of mass action, we studied there that in a law of mass action, when the rate of forward reaction becomes equal to rate of reverse reaction, then we take the ratio between the products and reactants molar concentrations, and that ratio gives a new constant that is called equilibrium constant. Equilibrium constant can be defined in a such way that it is the ratio of the product of the concentration of the products raised to the power of coefficient to the product of the concentration of the reactants raised to the power of their coefficients as expressed in a balanced chemical equation. To understand this definition, let's take an example that Kc we know is equal to C into D raised to their power of coefficient small c and a small d over means ratio over a into b raised to the power of their coefficient small and small b. When we defined the equilibrium constant Kc, we said that it is a ratio. The ratio is indicated in this line. This line shows the ratio between two things. One thing is the molar concentration of products, and the other thing is the molar concentration of reactants. Now, what are the products here? The products are C and D, and we have taken their products and their power are raised to C and D over the product of the reactants A and B, and their product mean they are multiplied to each other, and the coefficients are taken as their powers, and these coefficients are small and small b as in a balanced chemical equation. The coefficients are taken in fact from the balanced chemical equation, because in a definition we have discussed the power at the end that their coefficients as expressed in a balanced chemical equation. Remember, when we put numbers in a balanced chemical equation 2 or 3, so these numbers are usually known as their coefficients, which represent the number of moles of reactants and products, and in a law of mass action these coefficients becomes the powers of the molar concentration of products and reactants. So now you can understand, dear students, that Kc is the product of concentration of product. Product means the C and D are multiplied to each other. Product of the concentration of products mean C and D, and their product mean they are multiplied to each other raised to the power of coefficient, and coefficient are here small c and small d over, this line shows the over product of the concentration of reactants. Reactants are A and B, and we have taken their products mean they are multiplied to each other raised to the power of coefficient, and their coefficient small a and small b becomes their powers. So we can define Kc in a such way. Now again we can define the Kc, so you may understand the definition. It is a ratio of the product of the concentration of products means C and D and their product raised to the power of coefficients small c and small d to the product of the concentration of reactants raised to the power of their coefficients as expressed in a balanced chemical equation means A and B are multiplied with each other, their molar concentration are multiplied with each other, and coefficients becomes their power. Now hopefully you will have got an idea about the Kc. Now the next question often asked, what are the units of Kc? So now we will discuss the units of Kc, dear students. There are two options in units of Kc. Sometimes the Kc has a unit and sometimes Kc don't have a unit. The question is, when Kc has a unit? The answer of this question is very simple. When the number of moles of reactants and products becomes equal to each other, then there will be no unit of Kc. And if reactants and products number of moles, both of these are not equal in a balanced chemical equation, I mean to say the number of moles of reactants are not equal to the number of moles of products in a balanced chemical equation, then the Kc will have a unit. Now we can explain this with two examples. In one example we will see that Kc has no unit, and in another example we will see Kc as a unit. First of all, we have an example in which Kc has a no unit. Say H2 and I2 react together in a reversible reaction and forms 2HI. The equilibrium constant expression for this chemical reaction is HI molar concentration raised to the power of 2 over H2 into I2. Now we can derive the unit for this Kc expression. As we know, hydrogen iodide molar concentration will be expressed in moles per decimeter cube raised to the power of 2 divided by, because here is 2 is the power, divided by H2, and its unit will be mole per decimeter cube, and similarly I2, it will also have a unit of mole per decimeter cube. Now we can expand this equation as there is a square of this mole per decimeter cube. It means this value is can be written as 2 times. So we can write it again, mole per decimeter cube, etc. Now we will see that there are 2 mole per decimeter cube on the upper side, and there are 2 moles per decimeter cube on a lower side. So we can cancel these values. Mole per decimeter cube will be cancelled with the mole per decimeter cube, and this mole per decimeter cube will be cancelled with this mole per decimeter cube, and there will be no unit left which can be written over here. Therefore we can say that here mole per decimeter cube has been cancelled with each other, and there is no left mole per decimeter cube which would be the unit of Kc. And in this case, because there is no mole per decimeter cube left, therefore we can say that Kc in this reaction has no unit. Now the question is, when Kc can have a unit. For this we can have another example. Nitrogen reacts with a hydrogen in a reversible reaction to form 2NH3. The Kc expression for this reaction can be written as NH3 molar concentration raised to power of 2 over N2 molar concentration and H2 molar concentration raised to the power of 3. Now we can write the units for these molar concentrations for ammonia, nitrogen and hydrogen. So for ammonia it will be written as mole per decimeter cube power 2 over. For nitrogen it will be written as mole per decimeter cube, and there will be no power, and for hydrogen it will be written as mole per decimeter cube, and there will be a 3 power for this mole per decimeter cube, because hydrogen has a raised to power 3. Now we can expand these powers. This 2 power means it can be mole per decimeter cube can be written 2 times, and the power of 3 indicates that mole per decimeter cube for this reaction can be written 3 times. So no will write this mole per decimeter cube into mole per decimeter cube over mole per decimeter cube for nitrogen into, now we will write a 3 times mole per decimeter cube because there is a power of 3, mole per decimeter cube into mole per decimeter cube into mole per decimeter cube. Okay, this mole per decimeter cube will be cancelled with this mole per decimeter cube. This mole per decimeter cube will be cancelled with this mole per decimeter cube. Now the left mole per decimeter cube will be 1 over mole per decimeter cube into mole per decimeter cube. So it will become now 1 by mole. This power will be added, mole power 2 and decimeter power minus 6. Now we can cancel the inverse of this expression, and mole will be taken on upper side, and similarly the per decimeter cube will be also taken on a upper side. Inverse will be cancelled. Now the mole will become mole minus 2 and dm minus 6 will become simple 6. Now we can say that for this expression there is a unit for Kc, that is mole minus 2 dm 6. So it indicates that in some cases you can say that Kc has a unit, and in some cases the Kc has a no unit. When it is a unit, I repeat it again, when it is a unit, it has a unit when the number of moles of reactants, the products are not equal, and when it has a no unit when the number of moles of reactants are not equal to number of moles of the products. Student, hopefully you will have gotten an idea about the equilibrium constant. If we can make a summary of this topic, equilibrium constant is in fact a ratio between the molar concentration of products to the molar concentration of reactants, and it can have a unit when the number of moles of reactants are not equal to the number of moles of the products, and it will have a no unit when the number of moles of the reactants are equal to the number of moles of the products. This is a very important question. Hopefully students you will have gotten an idea about the Kc. In the next video inshallah we will have another topic. Till then, take care of yourself. Allah Hafiz.